Good afternoon. Today we will study observer moving away from the source. Last time we have studied observer moving towards the source, and for this at first you will write here source and observer here. I means source is here, so moving away is this. This is very easy. Okay. Can you do this? After doing this, as you know that when the source is at rest, that time there is no change in wavelength. So B wave, so F waves occupies V distance. There is only the change in the relative velocity. You can see here. Let's say, suppose the observer moves away from the source with a velocity u, as shown in the figure E. In this case, the wavelength does not change. This is the same statement which we have written yesterday, but relative velocity changes. As the wavelength does not change, you can write lambda prime equals to lambda equals to d by f. As the relative velocity changes, the relative velocity of the wave with respect to the observer is b minus u. How is this? Wave is going this side from the source with velocity v, and the observer also moving in the same direction with velocity u. If their direction is same, you can write b minus u to find the relative velocity. For opposite direction, addition; for same direction, subtraction. If f prime is the apparent frequency, this is the common formula that we have been writing. Okay, and velocity of the wave relative to observer, you can write your observer instead of o. And apparent wavelength, substitute the values v minus u upon v by f, and you will get f prime equals to v minus u upon v into f. Is v minus u is less than v, f prime is less than f. Okay? Thus, apparent frequency decreases when the observer moves away from the source. Our next case will be both source and the observer in motion. As we have separately discussed the source in motion and the observer in motion, now we will discuss both the source and the observer in motion. When both the source and the observer in motion, there will be several cases. The first case is observer leading the source. It means source on the agadi, observer inferior. Observer leading the source means that source is moving towards the observer, and in this case we can generalize that if source moves towards the observer, frequency is increased, and the observer moves away from the source, frequency is decreased. So their final frequency depends upon their velocities, and it is just a combination of source towards and observer away. Again, for the same case, source and the observer in motion, the second case is source leading the observer. When the source leads the observer, source moves ahead of the observer. In this case, f waves spread in v plus us distance is both the velocity and both the wavelength and relative velocity change, and the relative velocity becomes here v plus u, as waves always moves towards the observer with velocity v, and the observer also moving towards the source, this time towards the wave, so it becomes positive. And your final answer will be f prime equals to v plus u upon v plus us. So the what? So apparent frequency depends upon the velocity of the source and the observer, because we cannot say anything looking to this relation v plus u and v plus us. Thank you. Have a good day.